Hello, my name is Scott Keyser, and the presentation I made for today is going to be about nuclear energy and how it relates to the United States. Before we can get into why I think the United States should lead the way in developing nuclear energy throughout the world, we have to figure out what exactly is nuclear energy in the first place. Unfortunately, nuclear energy doesn't have much to do with giant fireballs in the sky and nuclear explosions. That would be cool, but that's not exactly what it is. There are two main categories of energy that we use to power the world around us. First, there's renewable energy, which comes from all the different sources you think would be natural, like wind and solar and things that keep reoccurring and can be used over and over again throughout time. The second kind of energy is non-renewable energy, which comes from things naturally found, but eventually will run out and we'll have to find a new source of energy that we can continue to use as our society gets older. These are things such as oil, coal, uranium, and natural gas. One key principle that all of these different forms of energy have in common is that they all create energy by making something spin. If you can make something spin, you can get energy from it. It's that simple. Whether it's a wind turbine spinning in the breeze or a river flowing over a turbine, it's all the same idea. You convert the kinetic energy of the spinning turbine into electrical energy that will go and power your smartphones, your house, your lights, and anything you really need electricity for. Now that we have an idea of how energy is converted into electricity from other sources such as the sun and the wind, natural gas to electricity, where does the process start for nuclear energy to be converted from uranium to electricity? Nuclear energy starts by trying to get uranium out of the ground. This is done by mining it, since it's a common substance that's found all throughout the Earth's crust, many different forms, mostly in uranium fluorides and oxides. When uranium ore is mined out of the ground, it looks like this yellow and black kind of just regular rock you would see on your day-to-day life. But it's only about 0.7% uranium, which isn't very much. So it is taken to a refinery where it is turned into these pellets, and the pellets are what is actually in the nuclear reactor, and these are roughly 3.5 to 5% uranium, which is a much higher percentage than what the regular ore is alone. Once the uranium has been formed into pellets, the pellets are then put into rods. The rods are then taken to the reactor to begin the reaction. To start the reaction, the uranium atoms are bombarded with smaller particles that will set off a process called nuclear fission. This involves breaking down the uranium and sending off particles in all other directions, which will start a chain reaction by starting more and more uranium atoms to start the reaction. This releases a lot of heat, which is used to heat up the water around the reactor, which is shown in pink in the diagram. This water is radioactive, so it is not good for it to be touched and contaminated by the other parts of the system, so it's kept in its own flowing chamber to only be used for this one purpose. This, although, is a very, very hot water system. Since it's kept under high pressure, it can't boil, so it can be heated well above regular boiling temperatures. It is then pumped through a pipe into the steam generator, which basically boils water and creates steam under high pressure. The steam is pumped through the steam line and is used to power a turbine, much like the diagram that we had before. The steam flows over the turbine and starts to spin, and it powers the generator, which is converted into electricity. Now, once that happens, the water condensates and begins cooling to be put back into the steam generator, which, when most people think of nuclear reactors, they see the large cooling towers, and that's where they would think the reaction is going on, when in reality, that's just a bunch of water cooling down, and that's what the steam leaving the top of it is. It's just water cooling down. And then once again, it goes back through into the steam generator, start the process again to get more power. Some of the things slowing down the expansion of nuclear energy are two main disasters that happened involving it. In Chernobyl in Soviet Russia, there was a meltdown at a nuclear reactor that caused a catastrophic explosion that erupted nuclear waste all over Eastern Europe and Western Russia. Another accident happened in 3 Mile Island in Pennsylvania in the United States, but it was a lot less catastrophic, and that's because of two main differences between the Eastern Soviet reactors and the Western American reactors. In an American reactor, the containment area, where the reaction actually takes place, has immensely thick concrete containment walls around the building, whereas the Soviet reactor did not have those containment walls, which allowed much of the waste to be strewn into the air and cause a lot of problems. Nuclear energy today, however, is on a much better upturn. Although the United States only has a small percentage of its own power coming from nuclear energy, it has a large percentage of the world's nuclear energy. And as you can see on this next chart, the world is making a lot of plans to go nuclear. A lot of countries, especially China, have made plans to create a lot of new nuclear reactors. Now we can go to my thesis. Why I think the United States should move forward with nuclear power is that to make things safer and avoid other accidents, it's much better to have one concrete design of a better product than to have a bunch of different designs that don't all work well together. If you have one main design, it's easier to communicate about problems and develop ways to troubleshoot issues if those should arise. If the United States can form their own set of rules and restrictions on how to run a nuclear power plant safely, as we have seen them do before, since their accidents aren't nearly as catastrophic as other accidents throughout the world, it will make the rest of the world safer and create a much better use of nuclear energy throughout the world. A couple more positives about why nuclear energy would be a great direction for the world to head in is that it's actually an extremely carbon-free source of energy compared to, say, coal or oil or things like that. The only thing that nuclear reactors give off is steam, which isn't a bad thing at all. And finally, when put in comparison with other carbon-free natural resources like solar and water power, compared to solar, nuclear power plants require 15 times less concrete, 75 times less steel, and 2,530 times less land to produce the exact same amount of energy. This difference, over time, as our society keeps using more and more energy to power all the things that we need to drive technology and things like that, this small form factor will really come in handy and will allow us to power everything we need in a relatively small amount of space and resources. In conclusion, I think that the United States should lead the push for developing nuclear energy because it will make things safer and more efficient if one nation steps up and really takes control and unifies the process. And it's clean and a strong renewable source that will last us for thousands of years until we can develop a better way of doing things.